Scientists have dedicated decades to studying and tagging sharks in a quest to unravel the mysteries of their behavior. However, a group of experts found themselves in shock when one of their tagged research subjects mysteriously vanished. This particular subject was a healthy 9-foot great white shark, tagged by researchers to monitor its movements as part of a study. 4 months later, the black box attached to the shark washed up on an Australian beach. The data retrieved from the device told a perplexing story: a sudden, sharp 1,902-foot drop in depth and a rapid temperature increase from 7.6 degrees Celsius to 25.5 degrees Celsius. The recorded temperature change strongly indicated that the shark had entered the digestive system of another creature. Researchers believe that the data suggested the shark had been consumed by something much larger, leading to the Smithsonian Institute's launching a quest for this mysterious super predator inspired by the Australian film The Search for the Ocean Super Predator. In 2014, filmmaker Dave Riggs commented, "When I was first told about the data that came back from the tag that was on the shark, I was absolutely blown away. The question that not only came to my mind, but everyone's mind who was involved was, what did that? It was obviously eaten. What's going to eat a shark that big? What could kill a 9-foot great white?" Scientists delved into the enigma, aiming to uncover the identity of this enigmatic killer. They made progress when they examined the migration patterns of great white sharks that entered the region where the 9-footer met its fate. Their research confirmed that all tracking data from the lost shark aligned with the behavior of their candidate, a colossal cannibal great white shark estimated to be 16 feet long and weighing more than 2 tons. Experts put forth theories about the attack, speculating that it could have been driven by hunger or a territorial dispute. Ultimately, they settled on a conclusion that was difficult to dispute. In the ocean, small sharks are eaten by larger ones. Scientists have grown increasingly concerned about the potential extinction of great white sharks, as their presence plays a critical role in maintaining the ecological balance of the ocean. The disappearance of apex predators like the great white could have devastating consequences, causing ripple effects throughout the marine ecosystem. For instance, without great whites to keep their numbers in check, sea otter populations may decline, allowing sea urchins to proliferate and devastate kelp forests, which are crucial components of the ocean's food chain. In 2019, Jacksonville University doctoral professor Brian Frank stated, "You would lose stability. But there are so many variables involved that it's hard to predict. Their prey would increase, resulting in the extinction of that third-level species. But this is difficult to model." The otters, urchins, and kelp are the classic examples. Now let's move on to the second part of our video. How do sperm whales sleep and why do they sleep this way? Whales, unlike sharks, require oxygen to survive in the ocean, as they lack gills for extracting oxygen from water. Consequently, whales must periodically surface to replenish their oxygen supply. Thus, it's logical that when they sleep, they prefer to be near the surface, allowing them to easily pop up for a fresh breath as needed. Sperm whales possess an extraordinary set of lungs within the marine realm. These expansive lungs enable them to dive to depths of up to 2,250 meters, where the air in their lungs is compressed to 1/4 of its surface volume. A sperm whale can spend approximately 90 minutes underwater before resurfacing to breathe. This remarkable adaptation not only facilitates deep-sea hunting, but also permits them to hold their breath while sleeping. Sperm whales can retain sufficient oxygen in their substantial lungs during slumber. However, there's more to the story of why sperm whales sleep vertically. This sleeping posture allows them to remain vigilant against potential predators. Orcas pose the most significant natural threat to sperm whales, but false killer whales and pilot whales have also been known to hunt sperm whales. Consequently, sperm whales need to remain alert even during sleep, a seemingly paradoxical requirement. Remarkably, much like dolphins, whales can keep one hemisphere of their brain active while they sleep, ensuring they remain alert, aware, and prepared to react if a predator approaches. Sperm whales employ various sleeping positions, including the vertical position mentioned earlier, swimming while sleeping, and sleeping while floating at the surface, a behavior known as logging. Sperm whales do not need the lengthy periods of sleep that humans require, as their 90-minute oxygen capacity would be inadequate for our 8-hour slumber. Fortunately, sperm whales typically engage in short naps lasting between 10 to 15 minutes. This catnapping behavior enables them to enjoy brief rest periods while remaining submerged and vigilant against potential threats. Research indicates that sperm whales spend approximately 7% of their day asleep, making them one of the least sleep-dependent animals on the planet. In fact, giraffes hold the title for being the least sleep-dependent animals, seldom sleeping for more than 5 minutes at a stretch in the wild.